Hello, good day. Welcome to our Computer Programming 1 final project presentation. We're here to introduce our console-based program entitled Load and Behold Beam Load Calculator created by Katoy, Cipriano, Hernandez, Tabay, and Vihanco from Bachelor of Science in Civil Engineering 1203 Group 8. This tool is designed specifically for engineering students and professionals to analyze beams with different types of load using Python. At the start, the program greets the user and displays basic instructions. It tells you this calculator supports point loads, uniformly distributed loads or UDL, and uniformly varying load or UVL, also known as triangular loads. It emphasizes that all inputs must follow SI units, meters for length, and kilonewtons for force. But it also allows unit conversion from feet, inches, and pounds. It then initialized a dictionary called previous calculations to store beam data for reference. So the first part, we have the main menu and beam type. The user is asked to select the beam type. They have three choices, which is simply supported beam, cantilever beam, or exit the program. If simply supported is selected, it further asks for the type of load. It includes the following choices. We have the point load, the uniformly distributed load, and the uniformly varying load.
User inputs and unit conversions. For each load type, the user inputs beam length, load values, positions if needed. The program then offers unit conversions. For instance, feet are multiplied by 0.3048 to convert to meters, and pounds are multiplied by 4.44822 to convert to kilonewtons. These conversions ensure all data is consistent for accurate calculations. For point load on simply supported beam, if the load is a point load, the user inputs load value, position from the left end. Using basic static formulas, the code calculates reaction at the left support or R1, reaction at the right support or R2. It uses the formulas R1 equals load times distance to right divided by total length. R2 equals load times distance to left divided by total length, in which results are both printed and stored. For uniformly distributed load, if the beam has a uniformly distributed load, the program calculates the total load as total load equals load per meter times beam length. Since it's symmetrical, both support carry half the load, so R1 equals R2 equals total load divided by 2. Again, results are both printed and saved.
Uniformly varying load or UVL. For a triangular load or UVL, the user inputs both the maximum and minimum load. The code calculates the area of the triangle, essentially the total load, and determines the centroid to split the reaction forces, in which the formula is equal to the total load is equal to the quantity of the maximum plus the minimum times the length all over 2. And based on the centroid location, it divides the reaction accordingly. Then again, the results are both printed and saved. For the cantilever beam formula, if the user selects the cantilever beam from the main menu, the program continues by asking what type of load is to be analyzed. These are the two options available: point load at free end and uniformly distributed load over entire beam. This part of the program focuses on determining the reaction force and the moment at the fixed support, which are essential for structural analysis. For the point load at free, if the user selects point load at free end, the program asks for two main inputs: the magnitude of the point load and the length of the beam. It also offers unit conversions for both values. For length, from meters to feet converted by multiplying by 0.3048, and to inches converted by multiplying by 0.0254. For the load, from kilonewtons to pounds converted by multiplying by 4.44822.
Once the inputs are entered and converted if needed, the program calculates the following. Reaction at the fixed end, same as the load since it's a cantilever beam. Moment at the fixed end using the formula moment is equals to load times length. The program then displays the results for reaction at fixed end. Reaction at fixed end, moment at fixed end in kilonewtons times meters. Uniformly distributed load in cantilever beam. If the user selects uniformly distributed load, the program again asks for the load per meter, the length of the beam. As before, the program supports unit conversions, meter, inches, feet. Load per meter can be kilonewtons, pounds, converted by multiplying by 4.44822. With these values, the program calculates the total load using the total load is equal to load per meter times length. Moment the fixed end using the formula for a cantilever beam with a full length. UDL, moment is equals to total load times length over 2. After the computation, it prints total load in kilonewton, reaction at fixed end, moment at fixed end in kilonewton times meter.
After each beam analysis, the user is asked, "Do you want to calculate again? Yes or no?" If the user enters yes, the program loops back to the main menu so the user can perform another analysis. This makes it convenient to test different loading scenarios in a single session. If the user enters no, the program ends the calculation loop and moves to the next section. Before fully exiting the program, the user is given one more option. Do you want to view previous calculations? Yes or no. If the user answers yes, the program displays all the stored calculation from the previous calculation dictionary. This is formatted neatly, showing all relevant input and output values for each type of beam and load analyzed during the session. If the user previously analyzed a simply supported beam with a point load, it would show beam type, length, load, position, reaction at left and right supports. Similarly, for cantilever beams, it shows beam type, length, load or meter, total load, moment at fixed end. That wraps up our beam load calculator presentation. With this Python-based program, users can perform structural beam analysis right from the console. This tool was developed to help civil engineering students better understand the fundamentals of beam reactions and moments in a visual, interactive, and educational way. Thank you.